Hey guys, this is 14.7 video. For the first question, we're going to be finding the cylindrical coordinates r, theta, c of the point with the given rectangular coordinates of square root of 2, square root of 2, negative 6. So to find r, we take the square root of 2 and square that, add it to the square root of 2 and square that because that's our x and y's. And then we square root that answer, and square root of 2 squared is 2 plus the square root of 2 squared is 2 is 4, square root of 4 is 2. And then tan theta, we have the square root of 2, which is our x, or our y, over the square root of 2, which is our x, which equals 1. So theta equals pi over 4, but do not take that at face value because arctan theta will only give you between pi over 2, and negative pi over 2. So you have to take it won't, because this would have given me 1, 2, but this quadrant right here, since they're both negative, it would have given me positive 1. So you have to consider the signs of x and y to determine which quadrant the angle is in. Because say this was negative or square root of 2 or negative square root of 2, then my angle wouldn't have been pi over 4, it would have actually been, sorry, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. And of course z is just boring old z in both of them, they just stay the same. So your cylindrical coordinates are now 2, comma pi over 4, comma negative 6. Next we're going to be converting from cylindrical to rectangular with the points r is 3, theta is pi over 3, c is negative 4. So to get our rectangular coordinates, we know that x equals r cosine theta, and 3 cosine pi over 3 equals 3 times 1/2 equals 3 over 2. And then y is r sine theta, which is 3 sine pi over 3, which is 3 times the square root of 3 over 2, which is 3 root 3 over 2. And again, the z's are the same because they're boring. The rectangular coordinates end up being 3 over 2, 3 times the square root of 3 over 2, and a negative 4. Got 2 more problems for this section that I'm going to work through with you. And we're taking the triple integral to find volume, where our z is bounded by 2 and 5, and the shape is bounded by the cylinders x squared plus y squared equals 2, and y squared plus, or x squared plus y squared equals 16. And just a little bit of housekeeping, our r squared equals 2 here, so r equals square root of 2. And our r squared here equals 16, so r equals 4. Which means our r is going to go from square root of 2 to 4. So our z goes from 2 to 5. Our r goes from square root of 2 to 4. And our theta is going to go from 0 to 2 pi because we're taking the whole circle, or cylinders. And it's going to be r dz dr d theta, which is the equivalent of dv in cylindrical. So integrating in terms of z, we just get a 3 because the z is just going to plug in those values of 5 and 2, and 5 minus 2 is 3. So I just went ahead and moved that out there. So now we have the double integral 0 to 2 pi and the square root of 2 to 4 of r dr d theta. So we have 3 times the single integral of 0 to 2 pi of 8 minus 1 because our r became r squared over 2. 4 squared equals 16 over 2 is 8. And then the square root of 2 squared is 2 over 2 is 1. So 8 minus 1 d theta, which gives us 7 times 3 is 21 times the integral from 0 to 2 pi d theta equals 21 times 2 pi equals 42 pi. And the last problem, which is why I went so fast on the others, takes a little while longer. So find the volume of the solid enclosed by the intersection of the sphere x squared plus y squared plus z squared equals 36, and the cylinder x squared plus y squared equals 5. And I know that a lot of you, since you know how to do 14.8 now, are going to want to do spherical here, but we're doing 14.7. We haven't technically learned 14.8 14.8, so we're going to be using cylindrical. So you solve for z, and you get the square root of 36 minus x squared minus y squared, which also equals the square root of 36 minus r squared. R squared equals 5, so r equals the square root of 5. And we're getting this whole sphere cut with a cylinder. So we're going to go from negative 36, or negative square root of 36 minus r squared to positive 36 minus r squared, square root of, and our r is 0 to the square root of 5, and since we're getting the whole thing, it's 0 to 2 pi of r dz dr d theta. So integrating in terms of z, we get the double integral 0 to 2 pi 0 to square root of 5 times 2 times the square root of 36 minus r squared r dr d theta. And the reason this is a 2 is because we ended up with this right here, the square root of 36 minus r squared, minus negative square root of 36 minus r squared, so we added them together to get 2 of them. And then we do some u sub, where our u is 36 minus r squared, and our du is negative 2r dr. So our limits go from 0, or 0 becomes 36, and the square root of 5 becomes 11. So we have the negative integral, double integral, from 0 to 2 pi and 36 to 11 of u to the 1/2 du d theta, which I don't like that negative, so what I'm going to do is I'm going to switch my limits of integration to make that be positive again. So we have 0 to 2 pi, 11 to 36, u to the 1/2 du d theta. And this becomes the single integral from 0 to 2 pi of 2/3 times u to the 3/2, which for 36 is 216, minus u to the 3/2 for 11, which is 11 root 11 d theta. And we end up with 4 pi over 3 times 216 minus 11 root 11. And that is the end of the 14.7 review.